Hello MYP3, this is your maths lesson for Monday the 3rd of May 2021. So just creating this video just for today's lesson. And we're just going to run through very quickly some of the notes for the current statistics unit. So some of the stuff that we've done already, some of the stuff that we haven't done yet. And the purpose of this is for you to take notes from the video, pause the video and repeat anything that you didn't understand, or pause the video just to take the notes. Okay, so pie charts we already talked about. So favourite football teams of MYP3. 5, 2, 3 and 8 for the different categories, adding up to 18. I actually deliberately kind of fixed that because 18 goes into 360, so I knew it would be nice round numbers. So anyway, Manchester United, it's 5 out of 18. So on the pie chart, it's 5/18ths of the whole circle, 5/18ths of 360 degrees. So you do 5 on the top, divided by 18 on the bottom, and then times 360 on the top, and that gives you 100 degrees for Manchester United. Others, for example, is 8 out of the 18, so it's 8/18ths of the 360. 8 on the top, 18 on the bottom, times 360 on the top gives you 160 degrees for others. So all of the others worked out in a similar way, and then the angles should add up to 360 because that's a whole circle. So you can pause that if you didn't get the notes for that first time round, and then we had that actually drawn out as a chart with the numbers of degrees according to what we worked out. Didn't label each section of the chart with the number of degrees, because when you're looking at a pie chart, how many degrees it is isn't really important to you. You're interested in the categories and the numbers relating to them. Line graphs we talked about can be used to illustrate data that are connected in some way, e.g. over time. So it makes sense to draw a line between the February temperature of 2 degrees and the March temperature of 4 degrees, because somewhere between those two you could expect that the temperature was 3 degrees. So because the temperature is constantly there and changing up and down over time, it makes sense to join those with a continuous line. But other types of bar charts or histograms doesn't always make sense to join the points up. Scatter diagrams. So we've done this in class. 2 types of data about various people, e.g. height and weight. Then you can plot them on a scatter graph to get an idea, or a scatter diagram to get an idea of whether the two things are related. So here are some athletes and their heights and weights in metric measurements. So we had all the data there, and I plotted that on a scatter graph. And I said, now find the mean average of the x's and the y's and plot this as a point. So we did that, and there it was. So the average x, the average height, versus the average weight was that point there. So that's x bar, y bar means the mean average of the x's and the mean average of the y's. So that bar notation means the mean average. The mean being the average where you add them all up and divide by how many there are. Okay, and then drawing a line of best fit through that data. Now that line of best fit must go through that average point. People often make the mistake of thinking it has to go through the kind of corner of the graph. That's not necessarily true at all. So just the best fit that you can get through that with more or less as many points above as below the line, and trying to follow the general trend of the data. So here you can see more or less as height increases, so weight increases. Taller people weigh more generally. So there is a general trend in that direction that we call positive correlation. As x increases, y increases. They both increase together, they're both correlated positively. Now there is actually a better way of finding the line of best fit, and you'll learn that if you happen to be studying that when you're about 17 years old. That involves kind of minimizing the distances between all of the points and the line that you fitted. So there are mathematical techniques for getting the best line of best fit. But as far as you're concerned at MYP level, it's just kind of doing it by eye and making sure that it goes through that mean point and follows the general trend with more or less as many crosses above as below. Okay, talking briefly about averages. So an average is a measure of central tendency. It gives you an idea of the location of the center of the data. So in everyday speech, when you say the average of something, people are normally talking about the mean. So the one where you add them all up and divide by how many there are. But there's also the median and the mode. They're types of average. So I don't know why I've actually put that note up in the middle of my thing about correlation. Maybe that note's out of order, but we'll talk about it anyway. So the median is the one where you line them up all in order, and the middle one is the median value, and the mode is the one that there's most of. I don't think that page should be there because my next page of notes is going back to correlation. So I talked about positive correlation, heights versus weights. Two variables are said to be positively correlated if they increase together. Taller people tend to weigh more. It's not always the case. Sometimes you find some outliers where you get a tall person that doesn't weigh much or a short person that weighs a lot. Could also have negative correlation. So hours wasted watching TV versus exam score. So the more hours you spend watching TV, the less hours you're studying, or the fewer hours you're studying, I should say. So maybe the lower your exam score. Or it could be no correlation at all. So height versus IQ, intelligence quotient. No reason to assume that tall people or short people are particularly cleverer or not so cleverer. Not so clever. Did I say not so cleverer? Yeah. Anyway, so if you haven't got that in your notes yet, pause the screen and get it. So what did I do this for? So I've got some shoe sizes of MYP3. And I put them in order. So I took all those shoe sizes and put them in order just to figure out the mean, median, and mode. Okay, so this is kind of back to talking about means, medians, and modes. So perhaps that bit about average should be the next page after correlation. And then shoe sizes of MYP3, putting these in order. I've just put them in order and figured out where the middle is by kind of just counting in from both ends. And I find that the middle is somewhere between the 39 and the 40. So the median is the middle of the 39 and the 40. So the median is 39.5. The mean is where you add them all up and divide by how many there are. So adding up 35, 36, another 36, 37, another 37, another 37, all the way up to 43 and another 43. Adding up those 18 shoe sizes and dividing by 18, you get the mean average to be 39.4444 recurring. Add them all up, divide by how many there are. No idea why there's a picture of a dead angel there. Some kind of a joke that made sense at the time. The mode is the most frequently occurring value. So I've highlighted them here. There's more 43s than any other shoe size. That's the mode. Okay, so get that jotted down in your notes. If you haven't already, you shouldn't have already. And let's see what's next. Oh, quartiles and percentiles. Okay, so now it starts to get interesting. I talked about the median being the middle value. So out of these shoe sizes, the middle was halfway between the 39 and the 40. So we said that the median was 39.5. That splits the data into a bottom half and a top half. And then I took that bottom half and found the middle of that, and that was 37, shoe size 37. And then I took the top half and found the middle of that, and that was a shoe size 42. So I've got three values here, 37, 39.5, and 42, that split the data up into 4 neat quarters. So a quarter of the people, or 25% of the people, are 37 or under. The next 25% of people are between 37 and 39.5. The next 25% of people are between 39.5 and 42 shoe size. And then the top 25% of people are shoe size above 42, or I should say 42 or above. So this is all about quartiles. We've seen the median, the halfway value which splits the data into the top 50% and the bottom 50%, the middle value in other words. So in a similar way, we've got this thing called quartiles, which are three values that split the data into 4 quarters at 25% intervals. So you've got the bottom 25%, the next 25%, the next 25%, and the next 25%. So the smallest one of those, or the lower one of those, is called the lower quartile, or Q1. The top one of those that splits off the top 25% is called the upper quartile, or Q3. And then the middle quartile, you can call it Q2, but it's also just the median. So 3 values splitting the data into 4 parts are called the quartiles. Similarly, there's a thing called percentiles, which split data into 100 parts, although when we've only got 18 values to start with, it doesn't really make much sense splitting the data into hundreds. So when you've got large studies of very large populations and data about them, you might talk about percentiles. If you've ever done map testing, you might have had a score that was in the top 5%. So you can say you're at the 5th percentile, that kind of thing. But for small data sets, not so useful. So anyway, get that jotted down about quartiles in your books if you haven't done so already. Okay, so now I'm going to talk about interquartile range. So we looked at the shoe size. The lower quartile was 37. That was the value that cut off the bottom 25% from the rest. The upper quartile was 42. That was the value that cut off the top 25% from the rest. So the range from the bottom 25% to the top 25% is 40. So from 37 to 42, that's a range of 42 minus 37. So we say that the interquartile range is 5. There's a spread of 5 across, well, the middle 50% really. The middle 50% of people have a spread in their shoe size of about 5 shoe sizes. So we use the interquartile range to measure how spread out a set of data is. If there's not much data if there's not much difference between someone who's in the top 25% and someone who's in the bottom 25%, then that's got a low interquartile range and not much spread. But the more spread out the data, the higher the interquartile range. The more spread out the data, then the more spread out the middle 50% of people are. So just getting this jotted down in your notes, please. Pause the screen if necessary. So it says interquartile range. Consider the shoe size data we looked at previously. We looked at the median, brackets the value 50% of the way along, and the lower quartile, or Q1, that's the value 25% of the way along, and the upper quartile, Q3, that's the value 75% of the way along. So there's the data with those values highlighted, and then the interquartile range, so the middle 50%, in other words, has a spread of 42 minus 37. The interquartile range is 42 minus 37, which is 5. The higher the interquartile range, so go back and pause that screen if you didn't get it. The higher the interquartile range, the more spread out the data. So the IQ range, I'm using IQ to mean interquartile rather than intelligence quotient this time, is a better measure of spread than just the range. So if you want to know how spread out a set of data is, you could just measure the range, which is how far from the highest to the lowest, but really that's just kind of two values, whereas the quartiles are more influenced by all of the numbers, because the values of all the numbers put them at the 25% and 75% positions. So we're writing down the higher the interquartile range, the more spread out the data. The interquartile range is a better measure of spread than just the range, and there's a little star there reminding you that range is highest minus lowest, because it is more influenced by all of the numbers in the data set. Examples. Example. Here are some test scores. Maths, science, English, and then I want you for each set to calculate the mean, median, range and interquartile range. Which set of results is most useful? So you might notice that, I mean, the math scores look okay, but the science and English scores, well, they're a bit weird. So it might tell you about the science test that it was a very easy test because most people scored high, but there was still someone who didn't do well. And that might say more about the person than about the test. And then the English, lots of very similar scores. So for each of these sets of data, calculate the mean, median, range and interquartile range. Which set of results is most useful? Okay, so that'll be the end of this particular lesson. So I'm asking you to have written everything down that's in this presentation and to have calculated this thing for the last example so that we can talk about it during the next lesson.